This is a video reviewing how to complete the square. I'm going to show you guys two ways to go from a standard form of a quadratic equation to vertex form, and then you can choose which method you like. So please make sure you have a sheet of paper out. You don't need graph paper, but have your calculators, because I do want you guys to graph both the original or the standard form of the equation and the vertex form, just as a way to double check. So just to review, the standard form of a quadratic equation is where we see the trinomial. At most, you can have fewer terms, but you definitely need to see the quadratic term, and then either the linear term or the constant could be missing, but the quadratic term definitely has to be there, otherwise it's not a quadratic equation. And then here we have the vertex form, where we see y is equal to a times a quantity x minus h squared, and then it's either plus a v or plus a k. That, again, that just means the vertical shift, and then inside is where we look at the horizontal shift. All right, so get ready to follow along here. Here's our first example. We're going to do 4 of these. This is again in standard form. So one way to go through this is that we want to first move, and remember, we can't complete the square until our leading coefficient is a 1, which in this case it already is. So probably the way that you have seen this is that we're going to subtract the 32. We want to move the constant term to the other side. And I always say just leave a little bit of space here, because then we're going to have x squared minus 12x. And then completing the square is technically what we're doing is we're making the right side here a perfect square trinomial. So that's what we're doing. We're completing a trinomial to make it a perfect square trinomial. And we do that by taking half of the linear coefficient, half of 12, which is 6, and then we square it. And then that's what we add to each side. So combining our constants here, we're going to get a y plus 4, and then we factor this into an x minus 6 squared. And then we move the 4 back over, and then this is in vertex form. So we have y is equal to the quantity x minus 6 squared minus 4. Now remember, from this, we could determine the vertex. I'm just going to denote that with a capital V. It's always going to be the opposite of that inside number, because that minus sign is there already. So we're going to have a 6, and then negative 4 is our vertex. And then we also want to indicate what the axis of symmetry is. And in this case, our parabola is going to open up. So our axis of symmetry, all of these parabolas are either going to open up or down. So our axis of symmetry will always be a vertical line, and it's going to go right through the x value here. So it's going to be x equals 6. Now, to show you a slightly different way of getting this in vertex form, sometimes it's a little quicker. So we're going to leave everything on one side. And as long as, I'm going to leave a little bit of space here though, as long as our leading coefficient is 1, we don't have to factor anything out. So what I'm really looking at here is I'm going to complete a perfect square trinomial, but I'm leaving, it should be a 32. I'm leaving the 32 over here. So in this case, what I'm going to add to this side is still going to be the 36. But instead of adding it to the other side, I'm going to keep everything over on one side. So technically, I added a 36 to this side. So to keep it balanced in a way, I need to subtract a 36. And then what I want to do is, again, just factor the perfect square trinomial. This gives me x minus 6 squared, and then here's my minus 4. And we got to that vertex form a little bit quicker. And it still has the same vertex and axis of symmetry. All right, so go ahead and graph on your calculator, pause the video, go ahead and graph the original function, and then the function in standard form, and then in vertex form. You should get the same parabola if we did this correctly, and then check for the vertex and axis of symmetry. So pause the video, go ahead and graph it, and then resume play, and I'll show you what I graphed as well so you can compare. Okay, so notice I have both functions already graphed here. If you're not familiar with it, all you have to do is hit tab after you graphed one, and then you could type in the other one. In order to graph the vertical line here, I just went to menu. I went to graph entry edit, and then to relation, and then that allows me to type in vertical lines. So not everything has to be in like y equals form, a slope intercept form, or any other kind of form where y equals. We could type in standard form, we could type in point slope form. So a really nice feature with this calculator. But that's how I was able to type in the vertical line there to check for the axis of symmetry. And then I just went to menu, 6, minimum here. It asks you to choose which graph because I have two graphs up here. So I just click the first one and then I click on the left of it, a little bit to the right of it, and then that gives me my vertex that we could double check is 6, -4. All right, let's take a look at our second example. Now this one has a leading coefficient of 2. So one way to do this is to start by dividing everything up here by 2. And then we also want to move the constant to the other side. So I'm going to do this all together here. So I'm going to get a minus 155 over 2. And then over here, we're just going to get an x squared minus 18x. Now this is where I'm going to add to complete the square here, figure out what to add to each side. So half of 18 will give me 9. 9 squared is 81. Now because I have a fraction over here, I want to get common denominator. So 81 over 1 is really 162 over 2. I want to already turn that into an equivalent fraction here. And then this will allow me to combine it. So I'm going to get y over 2. This will give me 7, positive 7 halves. Over here, I'm going to factor into the quantity of x minus 9 squared. I'm going to subtract 7 halves from each side. And then ultimately multiply everything back by 2. And then we're going to put the 2 in front of that quantity here. So we're going to get y is equal to 2 times the quantity x minus 9 squared. And then this will give me a minus 7. All right, so looking here, our vertex is going to be a 9, -7. Our parabola should also open up. One thing I want to point out is notice the a that's right here is the same a that's up here. They should be the same. They're representing the same coefficient here. So because it is 2, it's positive, our parabola will open up. Our axis of symmetry, again, is going to be a vertical line. It's going to be x equals 9. Now to show you the second way to do this, we're going to start with the same standard form. And I want to keep everything on one side. So what I want to first do is just from the first two terms, I need to factor out the 2. So y is going to equal 2, not the x, just the 2 for a common factor. I'm going to have x squared minus 18x. I'm going to leave a little bit of space, and then we're still going to have the plus 155. Now I complete the square inside. So again, half of 18 is 9. 9 squared is going to be 81. But I didn't just add an 81 to this side. When I go to distribute this 2 back, I'm really adding a 162. So then I subtract a 162. So then here I just factor 2 times the quantity x minus 9 squared. And we avoided fractions this way. And then I get the minus 7 here. So a little bit quicker of a method if you wish to practice this. All right, so again, pause the video, go ahead and graph both the standard form and the vertex form on your calculators. Double check, make sure you don't actually have to graph the vertical line on your calculator. You could picture it. So just double check the vertex and the axis of symmetry. So pause the video and then resume play once you have that done. Okay, so here I have both of them in standard form and vertex form graphed. Here is the vertex at 9, -7. Axis of symmetry is x equals 9. All right, if you want to try this, either method, pause the video first, work this out, and then resume play to check. So again, in this one, we have a leading coefficient that isn't a positive 1, so I have to get rid of that -3. I'm going to start by dividing everything up here by -3. And just be very careful watching your signs. So here we're going to get an x squared. We'll get a plus of 14x and then plus 138 over 3. Next, I want to move that 138 over 3 to the other side. Leave a little bit of space here, and then we have x squared plus 14x. So to determine what to add to each side, half of 14 is 7. 7 squared is 49. Now over here, I need to triple the 49 because I want to put it over a denominator of 3. So this will actually give me 147. So I'm going to get y over negative 3. This will give me a positive 9/3. So positive 9/3 will just turn back into a 3, which is nice. And then factoring this, we get x plus 7 squared. So I want to subtract the 3. And then multiply everything by negative 3. So this will give me y is equal to negative 3 times the quantity x plus 7 squared. And then I'll get a positive 9. So here, my vertex is negative 7, 9. My parabola, because A is a negative 3, my parabola is going to open down, and my axis of symmetry is going to be x equals negative 7. Now, if you chose the other way I just showed you on how to complete the square here, this will be the process you could check. So what we're going to do is just out of the first two terms only, we factor out the negative 3. So again, we need to watch our signs. So we're going to get an x squared plus a 14x, leave a little bit of space to complete that square, and then minus 138. So again, half of 14 is 7. 7 squared is 49. But we didn't just add a 49 to this side. We added a negative 3 times 49. So we're really adding a negative 147. So that means I need to add a positive 147 here. So now this gives me y equals negative 3 times the quantity x plus 7 squared. And then over here, I get the positive 9 again. So we could see that those match. Same vertex and axis of symmetry. Again, because A is negative 3, our parabola is going to open down. Pause the video again, graph the standard form as well as the vertex form to check. Check your axis of symmetry and the vertex as well. So pause the video. Okay, and here is everything graphed for example 3. We have both the vertex form and standard form. Here is our vertex here at negative 7, 9. Axis of symmetry is x equals negative 7. All right, one more example. Go ahead and pause the video and see how you can work this out before you check your answers. All right, if you notice here, the leading coefficient is a fraction, so I want to multiply by a negative 2 in this case for one method, or factor out a negative 1/2 for the other method I was showing you. So right here, I'm just going to go through and multiply everything by negative 2. So we're getting negative 2y. This will now give us an x squared. Multiplying this by negative 2 will give us a positive 10x, and then just a positive 23. So now I can move the 23 to the other side by subtracting it. We'll leave a little bit of space. To complete this square, half of 10 is 5. 5 squared is 25, so I want to add 25. Good news is we don't have any fractions here to work with. So we're going to get a negative 2y. This will give me a plus 2. And then over here we'll get x plus 5, that quantity squared. So I want to subtract 2. And then divide by negative 2 very carefully. So again, because we're dividing by a negative 2, I just want to write for the quantity here the negative 1/2 out in front. Remember, the a value up here needs to match the a value in the vertex form as well. So we're going to get y is equal to a negative 1/2 times the quantity x plus 5 squared. Negative 2 divided by negative 2 will give us a positive 1. So here our vertex is negative 5, positive 1. Our axis of symmetry is x equals negative 5. All right, without having to divide or multiply everything by negative 2, we're going to factor out a negative 1/2. Again, be very careful. So we get an x squared. Now, to get a negative 5x, our next term needs to be positive. We have to think half of what number will give us 5. So there's where that 10x comes into play. We'll leave a little bit of space, and then we'll have the minus 23/2. So again, in here, we're going to add 25. but I didn't really add a 25 to the side. I added a negative 1/2 times 25, which is a negative 25 halves. So I really want to add 25 halves to this side. So now this turns into y equals negative 1/2 times the quantity x plus 5 squared. 25 halves minus 23 halves is 2 halves, which is a positive 1. And again, we have the same vertex and axis of symmetry derived from this. Again, pause the video, graph the standard form as well as the vertex form, and check your two equations. All right, so here we have both the vertex form and the standard form. Again, our parabola opens down because our a value was a negative 1/2. Our vertex here is at negative 5, 1, and our axis of symmetry is x equals negative 5. So this was just a nice review of completing the square, hopefully maybe a slightly new approach to it. If you guys like that method, by all means, you can continue to do that. It's a little bit quicker sometimes. And then eventually throughout the course, we're going to find different ways to help us. Calculus is going to help us find even quicker ways to determine how a parabola opens and what the vertex is as well. So as always, guys, let me know if you have any questions.